to start by going over the answers to the 8-1 practice. Make sure that you have work shown. If all you give me are the answers that I have up here on the board, on the video, you will not get credit for the assignment. All right, so number 1A is 12.5, B is 26.8. That is using Pythagorean Theorem. Number 2, you're using Pythagorean Theorem on each one of these as well. If it's equal, then it's yes. If it's not equal, it is no. So you can see the answers. Number 3 on, you were to list whether it's obtuse, right, or acute, paying attention to whether the angle, which value is bigger. So remember we had, if it was a squared plus b squared, if that was less than c squared, then you have obtuse. If it is greater than the c squared, that means that you have acute. And if it's equal to the c squared, that is when you have that it's going to be a right triangle. All right, so that's it for the answers. Make sure you're looking at those. For the next section, you're finding the missing length of the triangle. So this kind of goes over a little bit of what was on yesterday's notes that you were working on your own. This is a right triangle, so I can use the Pythagorean Theorem. So think about this problem before you finish going through this video. Make sure that you can do it on your own. X is the hypotenuse, so we have 9 plus 81 equals x squared. Add those together, we have 90 is equal to x squared. In this particular course, you are allowed to keep that as a decimal. So on the calculator, you are using the square root key, and the square root of 90 is equal to 9.5. We're rounding to one decimal place on my lengths of sides. All right, notes for today. We're looking at section 8.2, number 1, and we are trying to find, when we have special right triangles, we're trying to find additional lengths. So what are some properties of squares that we already know? So think about, you have a square, like this picture down here. What do we know about it? So we know that it has equal sides. It has 4 90-degree angles. Now, something that you may not know is that you have diagonals. And diagonals line that goes through from corner to corner. It actually bisects the angles that it touches. So the diagonals bisect the angles. Now, bisect means cut it into 2 equal parts. So if I have a 90-degree angle, because I have a right triangle and I have squares, and you draw the diagonal inside the square, what shapes are created? Well, you have 2 right triangles. All right, what type of triangles do we have? Okay, so that's where our right triangles actually goes. So we have triangles, and then we have right triangles. And if I have right triangles, that means we can find the lengths of the diagonal, and we can do that by using the Pythagorean Theorem. So remember what the Pythagorean Theorem was? A squared plus b squared equals c squared. All right, so one other thing is true about those triangles. Not only are they right triangles, but because it comes from a square, they're also isosceles. So they have 2 sides that are equal, which means they also have 2 angles that are equal. And so because one of the angles is 90 degrees, that means the other 2 angles are both 45 degrees. All right, so that's the idea of what we're looking at for today's work. So I have an isosceles right triangle, and we're trying to solve it by using the Pythagorean Theorem. So I'm trying to find my longest side, which is my hypotenuse in this case. So 9 plus 9 equals x squared, and so my x squared equals 18, and x is equal to square root of 18, which is approximately 4.2. Now, for those of you that are good with radicals, this radical actually becomes 3 square root of 2. If you're not, you'll cover that next year. So that means on this problem, my legs are both 3, and my hypotenuse is 4.2, or 3 radical 2. All right, looking at the next one, number 2. My 2 sides are 11. So 11 squared plus 11 squared equals x squared. Doing the math with that, I have 242 equals x squared. And so my legs are both 11, and my hypotenuse is 15.6, also known as 11 square root of 2. Next one, same idea. 5 squared plus 5 squared equals x squared. 25 plus 25, which equals 50. And so that value is equal to 7.1. And these both legs are equal to 12. Sorry. Legs are both equal to 5. So we have a pattern that's happening here. These are called 45, 45, 90, or 45, 45 right triangles. And if you look, the legs, notice, are both always going to be exactly the same value. And the hypotenuse is a decimal. And that decimal comes from the side leg multiplied by radical 2. So the length of the hypotenuse is the length of the leg multiplied by radical 2. So to abbreviate that, hypotenuse equals a leg multiplied by the square root of 2. So if I'm trying to find the hypotenuse and I know the leg, I can simply multiply by radical 2, and I don't have to use the Pythagorean Theorem. All right, well, what if I want to try to find a leg? Well, the length of the leg is the length of the hypotenuse divided by 2. So if my goal is to find a leg, I want to take whatever the hypotenuse is and divide it by square root of 2. All right, so find the lengths of the missing sides. Use decimals to answer to the nearest tenth. So make sure that you pay attention to what kind of triangle you have, because we're going to deal with a couple different triangles through the course of this. All right, so I have a 45-degree angle, which means that this other angle has to be 45 degrees because I have a right triangle. The legs of the right triangle on the 45, 45 are equal, so my x value is equal to 20. My y is my hypotenuse because it's opposite of the right angle. The hypotenuse, that square, always points to the hypotenuse. All right? And so if I'm trying to find my hypotenuse, I'm going to use up here my leg multiplied by the square root of 2. So my leg was equal to 20, and I'm multiplying by the square root of 2 to get my hypotenuse. So on the calculator, rounding to the nearest tenth, so one decimal place, the answer would be 28.3. All right, next picture. I've got the radical in there. You can keep it with the radical. So those are my two legs. They are equal to each other, so they are 2 radical 2, which if you change it to a decimal, which you should be 2.8. All right, so how do I find the hypotenuse? The hypotenuse is equal to the leg multiplied by the square root of 2. Well, the leg itself was already a square root, so it's 2 square root of 2 multiplied by square root of 2. You can just do that on the calculator. Or, if you want to use your algebra skills, radical 2 times radical 2, radical 4. Radical and square root are used interchangeably. So this is going to give me square root of 4, but the square root of 4 is 2. So this 2 comes down, gets multiplied by the 2 from the radicals, and 2 times 2 equals 4. All right. Multiply a radical by itself, you always get the number underneath. Problem number 6. This time I'm given the hypotenuse, and I'm going to try to find the leg. So the leg is equal to the hypotenuse divided by the square root of 2. So my hypotenuse is 24 square root of 2, and I'm dividing by square root of 2. You can do it on the calculator, or square root of 2's just cancel, and so that means my legs are both equal to 24. It's a 45, 45 right triangle. Those legs are always equal. All right, last problem, number 7. So I have my 16 is given. All right, 16 is opposite of the right angle, so that means it's my hypotenuse. And the two legs that form the right angle are both the L's. If you think about the right angle, it's the letter L when you turn it around, so it's forming the legs. So if I want to know my leg, same as the last problem, hypotenuse divided by square root of 2. So it's 16 divided by square root of 2. That one you're going to need to use your calculator for it, and it's going to equal 11.3. So I have 11.3 on both of these. All right, make sure you get the notes, or make sure you get the assignment that goes with this for section 8.2, number 1.